Good day, everybody. This is lesson 2 for statistics for grade 12 essential math. All right, outliers. There's a very famous book that was written by a guy named Malcolm Gladwell. He's an economist, and it's called Outliers, and it looks at what makes people ridiculously successful compared to their peers. Why can I take, say, well, why is it that there's maybe, in all of hockey, there's one guy who can play like Connor McDavid? There's lots of guys close, but there's always that one guy who's just way more skilled than all of his peers. And of course, every sport's got that person like that. And that's not just true of sports. Whether it's, why is there always kind of one guy like Stephen Hawking or Albert Einstein who just seems smarter than everybody else, better in their field than all their other people? Those people are called outliers, and that book kind of explores, well, what makes outliers outliers? Here in statistics, an outlier is one factor that can influence mean, median, and mode, specifically, especially mean. An outlier, or outliers are numbers that are widely separated from the other numbers in the data set. An outlier is a value that lies outside and is much larger or smaller than the other numbers in the data set. Widely separated is the first blank. All right, here's our first example. First of all, this booklet can't count to 6. 1, 2, 3, 4, 5, 6. So can you change the word 5 to the word 6? There we go. So there are 6 people in a group, and here's their heights. 61 inches, 61 inches, 63 inches, 64 inches, 66, and 85 inches. Anybody know how tall 85 inches is in feet? That would be 7 feet 1 inch tall. I don't think we have anybody here at our high school that's that tall. I think our tallest student's about 6'7". So try to imagine. Picture that one kid in the hallway who is taller than everybody else, and add another half a foot to him, right? And that's NBA center kind of tall, right? Because there's a few guys in the NBA that are over 7 feet, right? Shaq's like 7'2", well, he's not that tall anymore, but he was when he played, right? Yeah. So anyway, there is a outlier in this data. First, we're going to figure out what is the mean, median, mode with that player in it, or with this guy in the suit in it. So the mean here is I'm going to add up 60 plus 61 plus 63 plus 64 plus 66 plus 85. And you know what? There's a nice shortcut way to do this. How about you just go, there's 1, 2, 3, 4, 5 numbers in the 60s. What's 5 times 60? 5 times 6 is 30 with a 0. And then what's 1 plus 1 plus 3 plus 4 plus 6? Well, 6 plus 4 is 10, 13, 14, 15. So there we go. All the 60s numbers add to 315. Oh, and then we'll add the 85. And we're dividing by 6, right? There's 6 people in this data. So that's 400 over 6. If you divide that, you get 66 point, it's actually 0.6 repeating. I'll round it to one place. 66.7 inches tall is my mean. Now, let's think about that mean for a sec. Is this a good reflection of the center of my data? Only one person is actually bigger than this number, the super tall guy. Everybody else is quite a bit shorter than 66 inches. This person, well, the second tallest person's, I guess, close. But then everybody else is significantly a couple inches smaller than that. So maybe a better way to say what the middle of my data is would be to do the median. And the median's easy. I just look at my 6 numbers and go, what's in the middle between 63 and 64? 63.5. And the mode, and hang on, my pen's dying. And the mode, well, there's one number that happens twice, 61. So what's the outlier in this data? So the 85-inch person is an outlier. Significantly taller than the rest of the data. So if we removed it, we would now have a mean where, and I'm not going to re-add all those numbers. That's kind of a waste of time. I already know that they add up to make 400. So if I remove one person, they now add up to make 400 minus 85. And we started out with 6 people. We're taking away one of those people. So my new calculation is 315 over 5, which works out nicely. That's a little better for an average. 63 inches, which, by the way, is now pretty much the same as the median. What's the median now? The median, if we take out the guy at the end here, so his number doesn't exist anymore. 63 actually is the median. And I know I have a good measure of average when mean and median actually agree with each other and they're the same thing. Notice it didn't change the mode any. There's still 2 people that are 61. And by the way, you can actually, for units, you can say inches as IN. Anybody know the other way to put inches as a unit? You can put 2 little quotation marks. That means inches. Okay. Anyway, so that's example 1. Yep. Okay, next. A little bit of notes. If there are 1 or more outliers in a set of data, then the mean will be strongly affected by these outliers. If the outliers are significantly greater than the rest of the data, then the mean will be higher than it probably should be. If the outliers are significantly smaller than the rest of the data, the mean will be lower than it should be. Outliers can affect the median. However, the median will still remain relatively unchanged. Let's look back to example 1 to sort of see what I mean by that. When we did our original mean, we got 66.7, a number taller than everybody else in the data except the one tall guy. But once I removed him, I got a number that was, pretty much right in the middle of the data. Literally, it is the median. So it's right in the middle of the data. Whereas the median was originally 63.5, it only changed by 0.5 by removing that one outlier. Okay. Unless 2 or more of the outliers are exactly the same value, the outliers will have no effect at all on the mode. However, if 2 or more outliers are the exact same value, these outlier values may be the mode, depending on what the other data is. Notice in our case, the mode didn't change. It was 61 before, it was 61 after. All right, another example. Karen was out pledging for a walkathon, trying to raise some fundraising. And she went to 7 houses and she got donated $10, $20, $5, $12, $5, $8, $5, $70, and $5. Oh, sorry, that's 8 houses. Sorry. Which measure of central tendency best represents the pledge amounts? Well, notice that it doesn't even ask us to calculate it. But if we were to do a mean, look at what would happen here. Okay? The mean would be, in fact, I will calculate it. The mean would be 70 plus all the rest of the numbers. Notice that the actual rest of the numbers, I think, add up to 70 themselves. That one house gave her as much as all the other houses put together. 10, 30, 35, 45, 47, 52, 60, 65, 70. Yep. So the mean would be 140 divided by 8, which is $15.56. Does it make sense to say that the average house gave her $15.56? Well, not really, when 1, 2, 3, 4, 5, 6, 7 out of 8 houses. Is there 8? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, my apologies. There's actually 9. Okay, I got to redo my data here. 140 out of 9. And I better punch that on my calculator. I had that as 8. 140 divided by 9 is, there we go, 15. Oh, I had the right number, though. $15.56. So again, out of the 9 places that she got donations from, to say that, well, my average was $15.56. That doesn't kind of make sense because 7 out of 8 of them didn't give her that much at all. That's not a good measure of center. So 7 out of 9 donations were smaller, so it is not a good measure of central tendency. How about median? If we did median, we would say, all right, let's see, let's line them up. 5 and 5 are the 2 smallest donations. Then we have an 8. Oh, wait, sorry, there's 3 5s. Then we have an 8. Oh, wait, there's 4 5s. Oh, my word, 4 5s. Then we have an 8. So then we have a 10. Then we have a 12. Then we have a 20. Then we have a 70. So the median would be the 5th number. 1, 2, 3, 4, 8. So the median is $8. This is a better measure of central tendency. So I think this one's going to be my winner. I think that's the best one. I guess there's one more I haven't checked yet. The mode would be $5 because it happens 4 times. But again, every other data point was more than that, right? So not a good measure either. Okay? Hang on. Okay. Next example. Justifying the removal of outliers. Outliers can affect the mean, median, mode, or the mean, median, and the mode. To lessen the effect that outliers have on these measures of central tendency, 2 things can be done. Number 1, you can just remove them and then calculate the mean, median, and mode. You can also calculate a trimmed mean. A trimmed mean means to help lessen, this blank is lessen, the effect of outliers on the mean. The trimmed mean is used. The trimmed mean is a measure of central tendency that ignores outliers in the calculation of the mean. The trimmed mean is calculated the same way you calculate an ordinary mean. However, a certain percentage of extreme values are omitted or left out. Usually you can omit the most extreme data, which ends up being the highest and lowest values. All right, so the Manitoba Ski Resort manager, or the manager of the Manitoba Ski Hill rental shop, collects data on how many snowboards were rented during the 20 Saturdays of winter. The data collected was as follows, and there's the number of things that were rented. Calculate the arithmetic mean. In other words, let's add all that up and divide by the number of things. Okay, I did this already to save some time. So if I add all these numbers up, I get 1,759. There's 20 numbers here, right? It told us that in the question. And that gives me an arithmetic mean of 88. Now let's calculate the trimmed mean. All right, so the trimmed mean, like it says in my notes, is you just ignore the outliers. All right, look at this data. Which numbers seem kind of way bigger or way smaller than the rest of the data? Can you see them? Notice there was one day where it was 156. None of the other numbers are even, like, barely over 100. 109 is the next closest. I see one that's also much smaller than the rest of the data. Do you notice it? The 32. So my trim mean will be remove the high and low outliers, which in this case is the 32 and the 156. Okay, so how do I remove them? Well, I don't really want to add up all those numbers again. Oh, but I already added them up once. So my new mean is to take 1759 and minus 32 plus 156. And then instead of dividing by 20 things, I am now 2 less than that. So when I do this, again, I've already punched this. This is 1571 over 18, which is 87. And notice that didn't make too much of a difference to the mean. How come it didn't make as much of a difference this time as it did in the last example where I had to throw out the super tall guy? Well, notice that one of the outliers was small, one of the outliers was large, so they kind of balanced in terms of the way they affected the data. If you have 2 outliers that are both way larger, throw those 2 out. You don't have to pick one from each end. Okay? But in this case, I threw out those 2, and that's my new mean. All right. Example 4. Another way you can do trim mean is by dropping a percentage of the highest and lowest scores. So to calculate the trimmed mean for example 3, this time we'll trim 10% of the data. So step 1, count the number of observations. Call that n. Step 2, reorder from smallest to biggest. Step 3, find what proportion is trimmed by turning this percentage into a decimal. Calculate the total number to be removed by multiplying n by the decimal I just figured out, and then recalculate. So, all right, here's how we're going to do this. First of all, the number of data points in the example was 20, right? There was 20 days where we counted how many snowboards we rented. All right, step 2, reorder from smallest to largest. Okay, so I already did this. It's 32, 53, 69, 74, 76, 80, 82, 83, 87, 89, 91, 92, 93, 94, 95. This is pretty consistent data. 99, 100, 105, 109, 156. All right, so now take 10% as a decimal and multiply that by the number of things, and it'll say, aha, if I'm trimming by 10%, I have to get rid of 2 numbers. And that's kind of what we already did with this example, so we don't have to calculate it again. We got rid of 1, 2 numbers, and we found out that the mean when we did that was 1759 over 18, which was 87. Oh wait, that's the wrong number. That was what it was beforehand. Sorry. Can you get rid of that? It was, what was it again? Oh, it was 1571. That's what it was. Divided by 18, which is around 87. Okay. If I decided to trim my mean by 20%, let's see, what would 20% be? 0.2 times 20. Then I'd have to take off that number and that number, because I'd have to take off 4 numbers. So if a question says trim the mean, trim your data by 20%, you do exactly what it says. What if the decimal doesn't end up being a whole number? You just round it. Obviously, you can't take 2.3 numbers off of a set of data. So you just have to round to 2. All right, next. I think when you guys look at EDSB, it says that your average is an arithmetic mean. That's kind of a lie. It's not. It's a weighted mean, because I pick, when I do your marks, how much everything is worth, and they're not all worth the same thing. Obviously, I make tests worth more than your little assignments, right? So there's weightings here. The weighted mean is similar to the mean. However, instead of each of the data points contributing equally to the final value, some data contributes more and some data contributes less. Each data value has a weight assigned to it. Data values with larger weights contribute more to the weighted mean. Data values with smaller weights contribute less to the weighted mean. If the weights are equal, then the weighted mean is the same as the regular mean. Suppose you had this choice. All right, I'm kind of curious to see what you'd think of this if this was really your situation. Let's say I came into class and I said, all right, they told us we have to make a final exam for this course. Would you like option A or option B, guys? A final exam worth 75%, all the assignments you did worth 5%, and then we'll do another unit test that's worth 20%. Option B, let's just make all three of those things about the same. 33.4% for the final exam, 33.3% for your assignments, and 33.3% for tests. So which one would you take? I don't know about you, but I would feel a lot of pressure in a 75% of my grade exam. So I think most people would probably say, I'll take the second one. Okay. So I'm going to say, I think most people would want to avoid a highly weighted exam. Like 75%, holy cow. Now that doesn't mean in your life you can avoid situations like that all the time. There are some courses out there where you might have a 100% exam. The whole course is your exam, right? If you want to be a lawyer, the bar exam is one thing. 100% of your grade that determines whether or not you get your diploma that says you can practice law, your license, is one exam, 100%, the bar exam. Most courses after high school aren't like that. I think the biggest ones at U of M that I've seen in first year is maybe 50% exams. Now, a weighted mean is useful in situations like these where not every part of a data set, such as assignments, exams, test marks, contributes equally to the mean. Let's do an example. All right, you want to determine your final mark in a class, and it turns out in this particular class, assignments are 75%, the midterm exam is 12.5%, and the final exam is 12.5%. You have received a mean mark of 76 on all your assignments. You have also received a 68 on your midterm, and you estimate, you think, I'll probably get about a 78 on my final. What do you expect your final mark's going to be? All right, so let's write the weightings first. Assignments are 75%, the midterm is 12.5%, and the final is 12.5%. So now let's calculate. So how much did we get on assignments again? We got 76 on our assignments. So 75% of 76 is how much my grade is for assignments. Right, remember 75% is 0.75? And I punched that button already. It's 57. All right, what did I get on my midterm? Oh, I only got 68 on my midterm exam. 12.5%, which is 0.2125 as a decimal, of 68 is 8.5 for my expected. And for my final exam, I expect, and again, I'm going to put this in blue because I don't really have this number yet. I just think this is what I'm going to get. I think I'm going to get a 78. So I'm expecting to get 9.75. So my expected total on this exam which will be my final grade, is 57 plus 8.5 plus 9.75, which gets me, add that up, you get exactly 75%. Well, actually, that's not quite exactly together. Here, let's run that through. I just realized I don't remember if I rounded this or not. So let's see, clear. So 57 plus 8.5 plus 9.75 Oh, yeah, it's 75.25. So, yeah, rounded, because we don't give you decimals of a grade. So that rounds to 70, come on, Ben, 75%. Okay, let's call this my A question. I'm going to add a B question to this. Can you write this down? Got enough room? Here's the B question. How much do you need to get on the exam to get a final mark of 80%? So remember, this blue mark didn't happen. I just kind of estimated. I think I'm going to get about 78% in the exam. How much do I really need to get if I want to aim for an 80 for a final mark? Well, all right, let's do this. Let's do this with algebra. Basically, I have to add these three numbers together and get 80, but I don't know that last number. And again, what do we do in math when there's a number we don't know in the middle of a calculation? We make it x. And what do you notice about this x? Well, let's figure it out. 57 plus 8.5 is 65.5. To get x by itself, I'd minus 65.5 on the other side. And that gives me 14.5. Does that mean I only need a 14.5% on the exam? Woohoo! No, that's not what it means at all. What does it mean? And kind of look at the question overall here. What is it telling us? Let you think about that for a sec. What's it telling us about the situation? It's like, oh, I need an 80. What do I need to write on this exam to get an 80? How much is the exam worth of my mark again? 12.5%. What if I had a perfect exam? If I wrote a 100% exam, I would have, well, again, my assignments were 57, my midterm was 8.5, and what is 100% of, or sorry, I said that backwards. Sorry. What is 12.5% of 100? Well, 12.5% of 100 is 12.5. Notice that's smaller than 14.5. Add that up, 78%. Therefore, the exam does not have enough weighted value to bring my average, I just misspelled average, my average up past 78% would be the maximum. Sad face. And this leads, if you're talking about education and schooling and high school and exams, this leads to some interesting conversations. There's people out there who have told us that, okay, well, we decided we weren't going to do an exam for this course this year. Next year, we'll be back to a provincial exam. And there's always the argument, well, how much should it be worth? And there's some people who say, well, you know, exams are very stressful. Let's make it worth as little as possible. Maybe, again, maybe 12.5% or 20% or 10%. The problem with that is, suppose I put in lots of effort at the end of the course and I work really hard, I study, I do lots of practice, and then my exam can't bring me up very much because it's not worth enough. Why would I bother doing all that work when I realize that it can't move the needle very much? So there's a very big drawback to not making an exam worth like 30% or 40%. Some courses might even say, tell you what, If your exam mark beats your term mark, we'll let you have that as your final grade. We used to do that here for pre-calculus. I don't think we're allowed to do it anymore. But anyway, lots of interesting conversations can happen from this kind of logic. I'd feel bad for this student coming to me saying, hey, I need to get an 80 or I can't get I can't get entry into this program I want to enter into. So what do I need in the exam? And then you got to tell them, hey, look at the math. If you got a perfect exam, you wouldn't beat 78. Those kinds of things happen. So don't approach a course thinking, I won't try very hard at the beginning and then I'll just ace the exam. Sometimes there isn't enough marks in the exam to help you out. All right, next example, last one. In one high school class, test 1 is 15%, test 2 is 25, test 3 is 10. Assignments are 20. Oh, I remember the days when we used to get away with a participation mark. That's the, okay, I look and say, all right, the kid participated in class and was paying attention and wasn't on their phones. Of course, this is before the days when kids had phones in their hands. So you could just give them a 5% or sometimes even a 10% participation mark. We've been told that that kind of thing is frowned upon. Most of us aren't allowed to do that anymore. And then the final exam is 25%. Rhett got an 80 on test 1, a 73 on test 2, a 69 on test 3. His average of all his assignments is 83. He pays lots of attention in class and doesn't chat like the person chatting in class right now. Got 100 and then got a final exam mark of 65. What's his mark? All right, here is how you actually calculate marks. You go by the weights. How much of this mark do I get to count towards the grade? 15% of it. So it's 15% of 80. Plus, how much of this test 2 do we get to count? 25%. 25% of 73. How much of test 3? 10%. Plus 10% of 69. How much of this 83 in the assignments do I count? Plus 20% of 83. Participation. I get to count 5% of this 100. Now hold on a sec. 5% of 100. What's 5% as a decimal again? 0.05. Yeah, don't forget the second zero. Of 100. And then of the final exam, he only got a 65, but that's only counting as 25%. All right, I'm going to pause here and see if you get the same number that I do. Okay? So see if you can get this number. What's Rhett's grade? Try this at home and then come back to us. Okay? So punch buttons in your calculator and come back when you've got an answer. There we go. We're back. All right, we're back. I gave the class time to punch buttons, and this turns out to be exactly 75%. All right, so once again, I'm going to call this my A question. All right, you know what the B question is going to be? I won't write it out in words. I won't make you do all the writing. But let's say Rhett comes to me and goes, I need a higher mark than 75. What can we do? Suppose I make this offer. I say, Rhett, it's your lucky day. I'm going to make you this offer. You can either keep this mark. This is like, let's make a deal. You can either keep this mark, or instead of all of these weights, I make test 1, 2, 3, assignments, participation, and exam, all worth the same amount. Nothing's weighted, everything's equal. But I'm not letting you touch your calculator. You got to decide right now. Is that a better deal? Will you beat 75? What do you think? I want some participation here, guys. What do you think? Does everybody, first of all, understand the question? If I wasn't taking 15% of this number and 25% of this number, etc., if I just said, all these are worth the same, are you going to beat 75%? What do you think? What's that? Well, that's the question, isn't it? What are they all worth? How do you calculate an average if they're all worth the same? How would you calculate the average of these things? Hint, there's 6 of them. What would you do? You'd add them all up and divide by 6. So what do you think? Will adding these 6 numbers and dividing by 6 beat 75%? What's your gut telling you? On the one hand, that number is going to count for more now, right? Because right now, what is 1/6, by the way? Anybody know the decimal and the percent for that? It's actually around 17%. It's actually 0.16 where the 6 repeats. So if you go 0.1666, blah, 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 and you round that, that's 17%. So this would jump up to being 17% right now. It's only 5%. On the other hand, my worst mark of the year was my final exam. That would actually be worth less in this scheme, 17%. So what do you think? What if everything was weighted equally? Question mark. Okay, thanks. So let's see. If we weighted everything equally, we would add test 1, test 2, test 3, assignments, participation mark, and that sad exam that didn't go so good, divided by 6. So, what do you think? Turns out you get 470 over 6, which is 78%. So Rhett should have taken the deal. He would have increased by 3%. So there we go. And that's the difference between a weighted mean and just a regular old arithmetic mean where I just add them up and divide by the number of things I have. Here in our courses, everything we do is a weighted mean. No, those little assignments that you hand in are not worth nearly as much as your tests, etc., etc. All right, that takes us to worksheet 4B. You can get started on today, and I'll give you some time to work on it tomorrow.